So we begin with chapter 4. So equilibrium of rigid bodies. And so for in chapter 2 we talk about equilibrium of a point. Equilibrium of a particle. This is from chapter 2. So if we have if we don't have for chapter 2 we have if we don't have motion in x direction, if we do not have motion in y direction, so we should have summation f equal to 0 here. Now now we for chapter 3 we know we talk about rotation. So if for something to have no rotation, then the total moment about O is also equal to 0. Okay. Now and before we go on, and and these are the necessary and sufficient functions. So necessary and sufficient in Chinese are these two. Okay. And we go on with we first talk about equations of equilibrium in 2D. I'll come back to that later. Okay. And so we have summation f equal to 0 and summation m equal to 0. And so how many equations do we have in 2D systems? Summation f equal to 0. It means we have how many equations for 2D system? We have summation f x equal to 0 and what else? Summation f y equal to 0, very good. And then we have summation m equal to 0. So we have you can say we have summation mz equal to 0. Okay. Now, how many equations do we have in total? How many equations? So in total we have 1, 2, and 3. So we have 3 equations in total. So from your mathematics, so if we have 3 equations, how many unknowns can we have? So how many unknowns can we have? 1, 2, or 3, or 4? We have 3 equations in total, so how many equations can we have? We can have 3 unknowns, okay? This is called statically determinant. You may come across with the Chinese term in the future, okay? And ding. DET. This is a determinant, okay? Determinant. what sometimes that you may see problems with more than 3 unknowns in a 2D problem. Okay, so sometimes you will see problems that have more than 3 unknowns. These are called statically indeterminate. Okay, in Chinese that is 净土定. It means we cannot solve this problem. Okay. We cannot solve this problem by those 3 equations. This system can be still in equilibrium, but these systems can be in equilibrium, but we cannot solve them. We cannot solve them. So this is called statically indeterminate. It's okay. Before I go on talking about statically indeterminate systems, let's talk about one. Let's go back to the page above and talk about 3-point diagrams. So in 3-point diagrams, that I always talk about it. Very important to have a 3-point diagram before you do the mathematics. Okay, before the mathematics. So and a 3-point diagram should have 3 key parts. The first one is the contour of the free body. That what is your free body? Because as we can see in examples later on, that you can have different choices of free bodies. You can have a large free body. You can have, for example, that. Sorry, let me go back to let me go to page 20. Let's go back to this. Example. So in this example, I choose the free body as this one. But of course, you can choose the free body to be this one or to be this one. Okay, you can choose any one as free body, but you need to draw it out. You can choose this one, and I chose this one. Okay, so anything can be free body. So, but you need to draw it clearly. What is your choice of free body? Okay. So, how do you choose your free body? That is the first thing. The second thing is all external forces should be shown. This is the for your seniors that this is the point that uses the most marks, and sometimes because your seniors forget to put all the forces, all external forces there. It's okay. And including supports now. Including supports. And and also that if the free body has weights, that it should be marked, and the dimension and magnitudes of the known external forces should be drawn on there. And the last point, the third point is that the free body diagram should include dimensions. So we have 3 parts: contour, external forces, and dimensions. As I mentioned, that your seniors usually forget to mark all support forces. Now, and these are some hints, and so which how many forces that we should draw? So if a support prevents translation of a body in a given direction, the force is developed on the body in that direction. Okay, let's and if rotation is prevented and couple moments is exerted on the body. This sounds quite long, and let's take some examples. Let's go to the next page. So we have in 2D problems. In 2D problems, we have four major types of supports. So the first one is cable. So the first one is cable, and so for example, we have you have a column here, and then you have cables. The cables here. And for the symbol, and usually we simply have this one. This is you can, because this is we need this cable because we want to keep the column here, right? We put these cables here to keep the column here. So suppose we have this one. So can this for example, we draw this one. So for this column, that it can be moved in this direction because this cable can move with it. Can move in this direction, but because the cable has tension, it cannot move in this direction. Okay, so it can be moved here, but it cannot be moved there. So should I draw it here? This is okay, but the cable can, because the cable is kind that this one is it cannot be moved in this direction. Okay, so it can be moved in this direction, but not that direction. So because it's prevents movement, so we have a force in this direction. Okay. And so this is the first type, and the second type is roller joint. Roller joint is this one is a bridge, and for this bridge, it can because this is of metal, and it can expand or contract, so it can go this direction, and actually it can also rotate. So in later examples, in all in the statics and in mechanics of materials, we will draw it like this, and we have rollers here, and then you can move to the left and to the right, and this one can also rotate. You can move to the left or to the right, and you can also rotate. But we say it cannot go in it cannot go up or go down. Because I think you can see that it cannot go down, right? Because there is a floor here. So there's a floor here that cannot go down. So because movement is prevented up and down, so we have here we have one reaction force here. So you need the last one. Because it can rotate in this bar can rotate, so it does not have a force, and it can go left and right, so it does not have a force there. But here we cannot go up or go down, so we have a force here out here. And I'll open for questions after I talk about all these four terms. Okay, I'll just give you questions and I'll open for questions. The next time you will see in the questions is pin joint. Pin joint and pin joint in Chinese is this one. And this one is bearing is so for this type it is we usually fix it to the ground here, and you can rotate it. So you put something here that you can rotate. For this type, that the symbol that in statics or mechanics of material is this one or this one. Okay, this one or this one. Now, for this one, can we go left or right? For this part, can we go left or go right? No. So this one is you cannot go left or right. Can you go up or down? No. Can we rotate? Seems yes. So we have here we have two forces. One is Rx and one is Ry. So these are very good questions. So and this R is R is reaction, which is or support. Okay, so because these are supports. Sorry, these are supports, and of course that and these are of course you have different shapes of supports, but how do we draw it as forces? It's okay. Now to the last one. So sometimes we have we see something is fixed, and so we have poles. So we have poles like this. Of course, that's this go to the ground and it cannot move. These are fixed on the ground, and the symbol of this is this one. We simply have it on the ground. Of course, for this type of support, we cannot have left and right motion, and we cannot have up and down motion. In addition to these two, we have the third one. We do not have rotation. We do not have horizontal motion, we do not have vertical motion, and we do not have rotation either. So to draw support forces, so we have therefore we have Rx, and we have Ry, and we have ampere. So these are the common supports. Of course, sometimes we have different types, and I will you use this principle. You use you first think about, can it go in this direction? If you cannot go in this direction, add a force here, add a support force here, and then if you cannot rotate, then add a moment here.